everyone. Great to see you all this morning. Today, I'm going to talk about how we can collaborate to make technology move faster. As an academic, I spend a lot of time thinking about how come the ideas that we're coming up with aren't making their way out into the real world. This talk is about how we can better use what we already know about cybersecurity. In case you've forgotten to attend any other session in this conference, I'll start by saying two things. First, the future runs on software. We have smart homes, smart cars, and even smart dating. If you haven't read about the Tinderbox algorithm for automatically liking faces based on your previous likes, well, I'm not sure if you want to. But to get to this future, we first have to solve the problem of software security. As Casimir mentioned, hackers can control our electric skateboards, they can control our rifles, they can even control our cars. Some of these hacks take years to get fixed, and sometimes they never get discovered until it's too late. In academia, there are many ideas that comfort me. There are all these research ideas that promise to help secure our software. There are encrypted databases. There are mechanisms for replaying programs so we can find the vulnerabilities. There are techniques for scrutinizing our programs to find bugs before it's too late. And there are also mechanisms to write software that's provably secure. But the curious thing is that in industry, the state of the art is firewalls. So in this talk, I invite you to think with me about how we can get research ideas to make their way more into practice. In this talk, I'll first describe what I've been thinking about in academia, my own work on programming languages and security and privacy. Then I'll talk about some work I've done on better connecting academia with industry, so with startups, venture capital, and bigger companies. And a missing part of the piece is policymakers and consumers. So I'll end by talking about some of that. So I invite you to think with me about how we can better connect researchers to everyone else. And this isn't just about getting research out there, but it's also about giving researchers feedback about what it's useful for us to work on. So let's start by talking about what we already know. This is what we've been thinking about in academia. And something that many of us think about is how can we get security by design? Instead of finding bugs before it's too late or waiting for hackers to find our bugs, how can we design our systems with security and privacy in mind? And from my point of view, as a programming languages researcher, we're still living in the 1970s. Here are two screenshots of code from the popular HotCrap conference management system. Yes, that's what it's really called. And I don't expect you to read this code, but what I want to show is that in order to enforce security and privacy policies, programmers have to write conditional checks, if-then-else checks, across the code. If we think about it, it makes sense. If we look at all of the programming paradigms in mainstream languages, they've been around since the 1970s. Privacy and security were not concerns in the 1970s, and so it makes sense that languages weren't built with those in mind. And so if programmers want to protect sensitive data, everywhere that it's being used across the program, they have to check to see where is this data coming from, where is it going, what's the other program state that's allowing me to make these decisions. To address this problem, my PhD work has been about a new programming paradigm called policy-agnostic programming. The main idea is that programmers can attach policies directly to data, and the rest of the program can be written in a way that's agnostic to these policies, and the programmer can then rely on the language and the language runtime to enforce these policies automatically. I spent some time developing a programming model that provides mathematical guarantees about what it means for the programs to comply with these policies. And I also developed an implementation strategy that demonstrates this can work on real-world programs. And so I hope that policy-agnostic programming is what can take us into the 21st century of programming with security and privacy in mind. On the left here, we have our friend, the program with manually enforced policies. You have the conditional checks that are repeated across the program. And on the right-hand side, there are screenshots of code from the Jacqueline Web Framework, a policy-agnostic web framework that I've built as an extension of the Django Python web framework. And what you can see is that all of the policies are in one place associated with the data. What you can't see is that you don't have to write the policies as repeated checks anymore, but each of them needs to be written now only once. So by reducing the opportunity for programmer error, we can reduce the opportunity for information leaks. Now you might be saying, well, this sounds good, but how can we get this into practice? The next part of my talk is about why more of these ideas aren't going into practice and how we can do better with this. To answer this question, we first have to think about what the barriers are to industry adoption of these ideas. The first is that managers need to fight the status quo. They have to make arguments, often economic, about why they have to do things differently. So unless there's a catastrophe, it's often hard to justify using a completely new paradigm or tool. Same for programmers. Programmers struggle with legacy code. So even if they really wanted to take the time to learn a new language or a new technique, they have to make sure that this interoperates with all of the code that's been written before. So one way that we can think about tech transfer is through startups. Startups aren't burdened by the same problems that large organizations have. And in fact, there's been an increasing interest and investment in startups for security. Sam Altman, who's the president of the Y Combinator incubator, tweeted recently that he wants to invest in dozens of security companies in the next few years. But before we get too excited about this, we need to think about why there haven't been more security startups already. And my answer is that security is no tin dog. So let's think about the quintessential hot new Silicon Valley startup. I recently heard about Tinder for dog lovers, where you can post pictures of you and your dog, and you can swipe through to meet other people who also love their dogs. This has a fun concept. It has a slick design. It's so easy that even your toddler nephew can use it, and you don't have to change anything about your life in order to use it, except for maybe give up several hours of your day looking at dogs. In contrast, the startup that's going to help us secure our software is going to have a technical concept, probably verifiable only by experts, and because existing infrastructure is not designed with security in mind, it's probably going to require us to completely change the way the infrastructure already is. It's not really the sexiest startup proposition. In short, there are unique challenges for security startups. There's a concept that's probably going to be highly technical. There usually are not flashy demos. If you're doing more than penetration testing or bug finding, you can't just go into a company and wow them with your absence of bugs. And adoption of these technical solutions requires either the client to understand fully what's going on or trust the company fully that they're doing what they say they're doing. And finally, building a security product is quite different than building a technical security solution. Justin Somaini, who's the chief trust officer of Box, says that a major reason security products fail is because they're made by security people. Security people are doing back-end coding. They're not worried about user experience. Products are all about user experience. So to address this problem, a friend and I started an accelerator called Cybersecurity Factory. Justin is wearing one of our shirts. This tweet is from us. And it's an 8-week accelerator that gives teams $20,000 in funding, a network of seasoned security entrepreneurs, potential investors, and potential clients, office space, and legal support. We piloted our program this summer with 2 teams in collaboration with Highland Capital Ventures. One thing that our accelerator does that's different from any other accelerator we know is focused mentorship. So our mentors included seasoned security entrepreneurs and also heads of security at large companies. including Justin Somaini at Box, Max Krohn, who was the founder of OkCupid and Keybase, Raj Shah from Palo Alto Networks, and David Ting from Imprivata. Our two teams had not formed companies when they joined our program, and they're both going on to raise funding after the program. What we learned from the summer is that having this focused mentorship helps, but there's a final missing piece, which is how to motivate customers to actually pay for security. And if we think about security from a high-level view, it's a no-brainer that we want to all chip in and pay. There was a recent report from the Atlantic Council and Zurich Insurance Group that says that estimates that by 2030, an insecure internet would cost us $90 trillion, and in contrast, a completely secure internet would increase our net benefit by $190 trillion. And while I'm having some trouble imagining these trillions of dollars or what it means to have a completely secure internet, what this suggests to me is that there's a sort of prisoner's dilemma when it comes to security. In game theory, the prisoner's dilemma is an example where you have two prisoners, and if they cooperate, their combined sentence is the least, but the cost of one of them betraying the other is so high that it's theoretically optimal for both prisoners to betray each other. And for security, this seems to be the case. Individual entities lack incentive to secure their software. If you want to secure your software, you have to train your employees, your programmers have to spend extra time writing secure code, and finally, secure software isn't actually providing much competitive advantage right now. It's much more worth your while to develop a new feature. So I can't speak to the policy changes that can improve this, but I've thought a lot about what we can do with policies that exist. And what we can do is we can create a culture around caring about security and privacy. There are two main parts of this that I've thought about, and one is getting consumers to care more. You might have heard about how the Snapchat ephemeral photo messaging app has egregious privacy violations. They promise to delete their photos. They don't actually delete their photos. But the thing is, they're benefiting from this, it seems. Their estimated value is $16 billion, and they have 100 million users. It seemed that the worst thing that happened to them was a couple weeks of questionable press and some criticism from the Federal Trade Commission. And in fact, I'm the only person I know who deleted Snapchat from my phone, not because I passed the age of 13, but because I objected to the privacy practices that they had. So we can do a much better job of getting consumers to stand up for their security and privacy. The other part that I discovered this summer with the accelerator was that there are privacy standards, but people don't seem to be enforcing them. And what we found out was that it's because people aren't getting audited. So one of our cybersecurity factory teams spent a bunch of time talking on the phone with dentists. And they said, do you want our secure system? And the dentist said, no, we're happy just emailing around our x-rays and records because we're not getting audited. So what this showed us was, well, it seems that there are standards and that these standards say that people should care about our solutions. But if these standards are not getting enforced, then it's not going to happen. So we can do a much better job of working together and enforcing these policies. And if we look to the FTC, this requires technology for detecting when these policies are being violated so that something can happen about it. I'm running out of time, so I'll end by giving you a recipe for how we can secure our software. Number one, we ask smart people to come up with technical solutions. Pretty simple. Number two, we put the solutions into place. And usually the solutions don't work the first time around, so then, number three, we iterate. Pretty simple. But as you saw in this talk, there are some things we need to do in order to make this happen. First of all, we need to better connect research with industry, so the ideas that the smart people in academia are coming up with are actually making their way out into the real world. But to make industry care about these ideas, we also have to change the incentives for securing our software. And this whole process requires communication, and education. To end, I'd like to say that I'm incredibly optimistic about the state of software security, because there are so many smart people like all of you working on it, and there are many pieces that are already there. So I invite you to think with me about how we can open up these channels of communication and connect the pieces so that we can eventually have some approximation of a completely secure internet.